Hey friends. Okay, so today we are going to dive into lesson three, which is on simplifying rational expressions. Okay, in 30-2, our rational expressions and equations unit. Now, this is kind of the last sort of introduction sort of note. And then from here on in, we're going to actually start performing mathematical operations on rational expressions. So we're going to multiply, we're going to divide, we're going to add, we're going to subtract. Okay. But simplifying is a really, really important point. So we want to kind of build you into this before we do that, because when we get into operations on rational expressions, essentially you have to have a very, very clear understanding of factoring, of simplifying, of non-permissible values. All of those things come into play for every question. Okay. Okay. Awesome. Like last class, I'm just going to hide my head for one quick sec. Like last class, when we are simplifying rational expressions, the same rules as regular fractions apply. So whatever you do to the top, you got to do to the bottom. Um, when we are trying to make equivalent fractions, we need to make sure we're dividing or multiplying the top and the bottom, not adding or subtracting. Okay. As we would always reduce a fraction, we must always simplify rational expressions. Remember, never write an answer with a negative exponent. We know we have exponent rules from grade 10 that are somewhere in the back of our head there. If we ended up with 2 to the negative 1, we would want to write that as 1 over 2. So a negative exponent tells you to flip the base. Okay, so if your answer is 3xy to the negative 3, you're going to change that to 3x over y cubed like that. Okay, you never ever want a negative exponent in your answer. A negative exponent doesn't mean that your number is negative. It tells you to flip the base. Okay, that's another just little mistake that kids make sometimes. They think, oh, I can just bring that negative to the front. No, that's not true. They do two different things. Okay, so a negative exponent doesn't have anything to do with the negativity of the number. Rather, it tells you to flip the base. Okay, awesome. So let's try some examples together. The question says, simplify the following and state all restrictions. So what we want to look at here is essentially we want to think about this like a fraction, and we want to do kind of the reducing a fraction sort of feel to this, okay? So first, we want to state non-permissible values. Remember from our note yesterday, okay, non-permissible values or restrictions are the values for x that we're not allowed to have because that would cause a zero on the denominator. It would cause a zero on the bottom of a fraction, and that's no bueno, right? Because you can't divide by zero. So when I take a look at this, I'm going to say, oh, okay, friends, x is not allowed to be zero because if x was zero here, this whole thing would be no good. Okay. Now, I want to take a look at 14 over 4, and I want to say, hey, can I reduce that? The answer is yes. Both of those are divisible by 2. So what I want to think about is, hey, that will reduce to 14 divided by 2 is 7, and 4 divided by 2 is 2. Okay. Hey, if that stresses you out, let's just talk about that for a second. If you don't like doing that sort of stuff in your head, that's okay. You got a calculator to help you. Just don't write things as a decimal. Don't write this as 3.5. Okay. If you're going to go 14 divided by 4 in your calculator, that's okay. Just then ask your calculator to change it back into a fraction. Because when you ask your calculator to change things back into a fraction, it'll always give it to you in reduced form. So it will give you the 7 over 2 for you. Okay. Now, with x to the 5 over x squared, we want to take a look at, well, we could think back to grade 10, exponent laws. When dividing powers of the same base, we subtract the exponents. Okay, so x to the 5 minus 2, that would be x to the 3 there. Okay, another way to look at it, if you are kind of a more visual person, x to the 5 is like x times x times x 5 times, right? 1, 2, 3, 4, 5. X to the 2 is x times x. And then I could go, okay, well, x divided by x is 1, so that's gone. X divided by x is 1, so that's gone. What am I left with? I'm left with x times x times x, which is x cubed. Okay, so either way, whatever makes the most sense to you is perfectly fine there. Okay. Okay, next up, let's take a look at this one. Now, in this one, I have a negative in the front. That negative can go on the top. It can go in front of the entire fraction. Just don't put it on the bottom, okay? We don't like to have negative denominators. So for this guy, I'm going to go through the exact same process, okay? I'm going to think about this as a fraction and try to reduce it. I'm going to think about my non-permissible values first. So x can't be 0. And then I'm looking at 24 and 18, and I'm trying to think, okay, what can I divide out of there? And I can divide a 6 out. Both of those are divisible or reducible, if you like that better, by 6. So 24 divided by 6 gives me 4, and 18 divided by 6 gives me 3. So I'm going to end up with a negative 4 over 3. Let me just write that down for a sec. Negative 4 over 3. Now let's deal with the x's. I could look at this from an exponent law standpoint. I could say, okay, I'm dividing powers that have the same base, so I will subtract the exponents. 2 minus 3 is negative 1. And then I would say, okay, but I was just told like 30 seconds ago, I'm not allowed to have a negative exponent. So I'm going to flip that to the bottom and make it positive. Okay, so that would be x to the positive 1. X to the positive 1 is just x, so I don't need to write to the positive 1 there. Okay. Now, again, if you liked the visual thing that I did last time, that would look like this. Xx over xxx, and then we would take a look at, okay, x divided by x is 1, so it's gone. X divided by x is 1, so it's gone. And so I'd be left with 1 over x. X is on the bottom there, and that would take me there as well. Okay? Whichever one you like the best, your math teacher will be super happy. Okay, so negative 4 over 3x. Yay. Okay. Next up. Now, we're getting a little bit more complicated, but here is a very, very important question or statement, conversation, whatever you want to call it. This is super important because rookie mistake, kids look at this and say, oh, yay, I can cancel those out. No, you can't. Okay. But I want to try to explain why. Okay. When we cancel things out, what we're actually doing is we're dividing something from the top and something from the bottom. Okay. I can't do that unless the statement that I'm working with is all multiplication or division. Okay. If you look at this, this is not multiplication or division. This is actually a subtraction statement on top. It's not a multiplication statement on top. Okay. Now, in the same breath, if I had something that looked like this, I'm just making this up, okay? But what I want to do is I really want to make sure you can see the difference between these two things, okay? So I know I got kind of messy on this, so let me just take that away. I want you to see the difference in these two questions. This one, the top is being added or subtracted, okay? If it's being added or subtracted, I cannot divide something out like that, okay? Whereas this one, this is being multiplied now. Multiplied. Didn't quite know how to spell there for a sec. So in this one, it would be totally okay to divide those guys out, okay? Because the 15x cubed is now being multiplied by the 2x plus 7, not being added or subtracted to it, okay? This is a really important point, which is why, for those of you who think I keep repeating myself, maybe I do, but it's a very, very common mistake that kids make. So common, there's a picture to help you. Every time you do this, a kitten dies, okay? You cannot divide out terms that are common when they are connected by addition or subtraction to other terms, okay? All right, and so that leaves us with kind of a series of steps that I want to talk to you about. Essentially, the first thing you're always going to want to do is factor. Because remember, when we talked about factoring in our first lesson, I said factoring creates multiplication sentences where there wasn't multiplication sentences. Well, that's like super helpful to us because I can't simplify unless there's a multiplication sentence there, okay? Then we want to figure out what just happened to my ink because it wasn't there. Okay, then we want to state the restrictions. And then finally, we want to simplify. Okay, so those are going to be kind of the things I do in order, this order for like literally every rational question that I come up with, even as we go on to the next lesson and we start multiplying and dividing and the questions look more complicated, I'm always starting with these three things. Number one, factor. Number two, state the restrictions. Number three, simplify. Okay. All right. So let's do that. When I take a look at this guy, I can see that 5x is common on the top. So if I factor out a 5x, 15x cubed divided by the 5x that I'm factoring out will give me 3x squared. And then minus 5x divided by that 5x will give me minus 1. Okay, so I'm going to be left in a factored form of 5x bracket 3x squared minus 1. Now, I have created a multiplication sentence from this top guy. And so now I can take a look at this and say, yep, I am totally okay to reduce that fraction now. Now it's okay because I can divide both things by the same number, and that would be 5x. Now, before I do that, I want to make sure that I'm stating my non-permissible values or my restrictions. And so I'm going to say that x can't be 0. Okay, and then I'm going to think, okay, 5 over 15, that reduces to 1 over 3. And then x over x squared, I'll have an x on the bottom. So I end up with 3x squared minus 1 over 3x. Now, don't get caught. Don't get looking at this guy right here and saying, oh, can I do something with that? Dude, I just told you. No, you'll kill a kitten, okay? So this guy is your final answer. This is perfect. Okay, 3x squared minus 1 over 3x. Okay, awesome. Let's try another one. 3x minus 9x squared over 6x cubed. So again, going through this process, I want to factor first, then I want to state restrictions, then I want to simplify. So when I look at this, I can take out a 3x from the top. If I take out a 3x from the top, I'm going to be left with 1 minus 3x. Then I can look at this here and say, okay, 3 over 6 is 1/2. X over x squared, or sorry, x over x cubed will be x squared, okay? But before I simplify, I need to state those restrictions, those non-permissible values, okay? Remember, my order, factor, then restrictions, then simplify. So x can't be 0 in this guy. Okay, then I'm looking at this, as I just said, this will be 1 over 2, and this will be actually 1 over 2x squared. Now, I don't need the 1 there anymore. So my final answer will be 1 minus 3x over 2x squared, okay? Technically, you don't need these brackets here anymore. It's okay to have them there because I had them there here. It doesn't really matter, okay? If you had wanted to write this as 1 minus 3x over 2x squared, if you had wanted to keep that as a package, that's fine too. Doesn't really matter, okay? All right, awesome. 6x squared minus 8x over 3x cubed minus 4x squared. So this one, we're just adding a few layers here. Now we got to factor the front, factor the top and factor the bottom. Okay, but remember, the three things we're doing are always the same three things. Number one, we're going to factor. Number two, we're going to state our restrictions. And then number three, we'll try to simplify. So when I look at 6x squared minus 6x, I can see that I could factor out a 2x from that, okay? So let's just do this together. So I could factor out a 2x, and what would that leave me with? It would leave me with 3x minus 8x divided by 2x would leave me with minus 4, okay? Then on the bottom of this, I've got 3x cubed minus 4x squared. I can take out an x squared. That's what's common to both of these, okay? And then that would leave me with 3x minus 4. Okay, now that makes me super happy because I can see, oh, I've got a 3x minus 4 and a 3x minus 4, and I want to divide those out. Not yet, okay? You want to state your NPVs first. So I know that x can't be 0 because of the x squared. Then I got to think about this guy. Now, if this guy stresses you out, if you can't do this in your head, that's totally okay. What you're going to do is you're going to do a little sidebar, set it not equal to 0, and you're going to isolate for x. So we're going to add 4 to both sides. And then we'll divide by 3, and I can see that x can't be 4 over 3. Okay, so x can't be 0, and x can't be 4 over 3. And then I'd be ready to start the simplification process, okay? So I've done my factoring, I stated my non-permissible values, then I can say, oh, you know what? Look at this. I need a different color, but look at this. 3x minus 4 over 3x minus 4. Now, remember what that does mathematically is it gives me a 1. Okay, so that's why we can say they divide each other out because they divide into a 1. Then I've got x divided by x squared will leave me with just an x on the bottom. Okay, so my final answer is actually going to be 2 over x. Okay, 2 over x. Yay! Okay, awesome. Let's try another one. 2x minus 1 over 4x squared minus 1. Okay, so step 1, factor. Can't do anything to the top, but to the bottom, that's a difference of squares. Okay, a reminder, difference of squares factors into 2 binomials multiplied by each other. The first term is the square root of the first term originally. So the square root of 4x squared is 2x. So I'm going to have a 2x and a 2x. The back terms are the square root of the back term originally. That's a 1. Square root of 1 is 1. And then 1 gets added and 1 gets subtracted. Okay. Now I'm going to state my non-permissible values. Again, if you can't do it in your head, that's totally okay. Set them equal to 0 and isolate for x. And you'll get plus or minus a half there. Okay. Then we want to do the simplification. Now, the 2x minus 1s divide out. Very common mistake I see kids make at this point is they say, oh, great, my answer is 2x plus 1. No, it's not. A reminder, when you divide these things out, you're left with a 1. If something was on the bottom of the fraction, it can't randomly appear at the top of a fraction, okay? So if all of my numerator goes away, I'm left with a 1. Okay, so my answer there will actually be 1 over 2x plus 1. 1 over 2x plus 1. Okay, that's another really common mistake I see kids make. So just make sure you're, and we just get caught into doing things too quick, I think is what it is, right? So just slow down, enjoy the ride, and make sure you're paying attention to those little details. Okay. All right, friends. Let's summarize what we've done so far. I'm just going to take that ink out. Okay, so remember, factor completely. That's always step 1. Okay, then step 2, you're always going to state the non-permissible values before you start the simplification program or simplification process. It's not a program. Then you're looking at dividing common factors. Okay, that's the whole simplifying. You essentially divide common factors out in the numerator and the denominator. Homework. Homework counts for 100%, makes me pass 30-2. That's a joke, but it's not really a joke because you got to make sure you're practicing this stuff, right? You got to make sure you give yourself time to process. And by practicing, it keeps things in the forefront of your brain, okay? And it's much better for your brain to process if it's sitting up here than if it's stored back in useless information section of your brain, okay? All right, you guys can do this. I know you can do this, okay? So try some homework. Again, if you have any questions, make sure you get in touch with me. I'm more than happy to help. And remember that you can do this, okay? Thank you very much for watching. Thank you very much for sharing these videos with your friends. And of course, thank you very much for subscribing to my YouTube channel. It really helps, and I really appreciate it. And I really appreciate you guys. You can do this. Take care, guys.